This is a demonstration of the OtterTune AI-powered database optimization framework. Database management systems are the most important part of every application stack. But the challenge is that modern database systems have gotten so complex that they're beyond the ability of any human to reason about in order to optimize and tune them. And this is necessary in order to get the best performance for your application because you want to tune the database system for exactly how the application wants to use this. And this has become a more pronounced problem as companies and organizations start migrating to the cloud, because in that environment, it's very easy to scale up your database system. So a lot of companies are just sort of throwing money at the cloud vendor to get bigger instance sizes with more hardware, more CPU, more disk, more RAM, and assuming that's going to paper over the performance problems. But we know that when we look at the results of this effort, throwing more money at the cloud vendor to get a bigger database instance size is going to produce diminishing returns. So as proof of this, we did a study a few years ago where we measured the performance of Postgres running on Amazon RDS using the TBCC benchmark, which is a standard workload people use to measure database performance. And we see is that as we increase the instance size, obviously the cost gets higher and higher, but performance tapers off. And beyond M5 8x large, you don't get better performance. So this is showing that there's an upper limit to how much better performance you can get if you just increase your instance size. So in order to get better performance, there has to be other considerations. And this is where OtterTune can help. OtterTune is an automated database tuning and resource optimization service. It's designed to use machine learning to automatically tune your database system according to how the application wants to use this. In the current version of OtterTune, we support databases running on RDS, both the regular versions and Aurora. And we currently support both MySQL and Postgres, including Postgres serverless. OtterTune started in 2020 as a spin-out of our research lab at Carnegie Mellon University Computer Science Department. And since then, we've been commercializing the technology. OtterTune has been shown to improve performance for Postgres and MySQL databases by up to 4x, and in some cases also reducing AWS costs by up to 50% with minimal human effort, meaning you point OtterTune at your database, let it do its thing, and you don't have to sort of micromanage it and babysit it while it runs. The way OtterTune works is that you first go to the website, sign up for an account, and then the OtterTune onboarding process will enable you to give OtterTune permissions on AWS to connect to your account and retrieve the information about your RDS databases. You then deploy the OtterTune agent, which is open source, in a Docker file, and that connects to your target database that you want to optimize. And then the OtterTune agent uses the standard APIs through SQL and other cloud calls to retrieve the runtime telemetry and information about your database system. So this would include anything that Amazon collects, CPU utilization, memory usage, any internal metrics that the database system collects, pages read, pages written, number of queries executed, and so forth, as well as additional information about what your schema looks like and anonymized query digests. The agent then sends that back to the OtterTune service, where it stores this in its repository with all the training data it's collected from other databases, and then it trains machine learning models that can predict the database system's behavior as it starts making recommendations and changes to your configuration. And then the compute engine generates new configurations and additional health checks that show whether your database is running correctly or not, which you then post back to the OtterTune service, and we can then expose to you through the web interface, through a REST API, or have OtterTune make the changes automatically for you on AWS. I now would like to give a demonstration of the OtterTune service to show you some of the features and capabilities. When we sign into OtterTune, we first land on the database dashboard view. The dashboard view shows the status of all the databases that are connected to OtterTune, as well as an overall health score of the fleet. This health score is a quick snapshot of OtterTune's assessment of the health of your database system. So is it running with the best configuration or not? We can then go to the database dashboard, where it shows us the health status of that particular database system. And then it provides additional information about what OtterTune thinks as the workload looks like. When we click the recommendations tab, we then see the list of all the various recommendations that OtterTune has generated for this particular database. So on the first page here, we see all the knob configuration recommendations for the system, including what OtterTune wants to set the value to and why it thinks that it should be setting this value. And there's the ability for OtterTune to apply this change automatically, or you can click the copy command line option to copy and paste this code and apply it for yourself. we can then click on the Indexes tab and see all the recommended indexes that are either unused or duplicated. And these are indexes that OtterTune has identified as not being used by the database system, and therefore they are wasting space and costing you money and slowing your system down. So OtterTune recommends that you can delete them. OtterTune will not delete your index for you automatically, so you can click on the Generate SQL command to see how to do this yourself. And then OtterTune will detect that the index has been dropped and update your score appropriately. Next, we can click on Query Recommendations. In this case, the customer only has one, and OtterTune provides information about how to fix this index to make it run faster. Next, on the tables view, we see the health status of the health check that OtterTune ran to determine whether your table layout on disk is efficient or not. In this case here, this database's tables have low fragmentation, and therefore OtterTune thinks that everything is okay. On the last tab, we see the additional checks that OtterTune runs against the database to determine whether it is running properly or not. In this case here, this particular database has been flagged for having poor memory utilization. For more information, visit OtterTune.com to sign up for your free trial.